Hello friends, today we are here to study TA model and church hypothesis. TA model is a model given in 1936 by Alan Turing. It is a simple mathematical model of computer used for computing capability of a computer. Turing machine is a finite state machine which consists of an infinite tape with a tape head that can perform read or write operation with one tape cell and move left or right. It normally accepts the input string, which on completing the computation enters to a final state, which is also known as the accepting state. Tape is used for giving input and for working storage. Here is a basic structure of Turing machine model. This is a tape which is infinite. B represents the blank and x1, x2, x3, x4 are the input and output tape symbols. This is finite control and this represents the read and write operations. The tape is divided into small cells with which consist of input or output tape symbols. Now comes the transition function. One move in a TM model does the following. Here Q is the current state, X is the current tape symbol. When this symbol changes from X to Y on moving left or right, the state Q changes to P. This is also a Turing machine as here Turing machine is represented as a physical computing device. This is finite control as we have seen earlier. This is an infinite tape read write head can which can read or write. Now we will see the formal definition of Turing machine. It is a seven tuple machine like Q, summation, T, del, Q naught, Q accept, Q reject, where Q is a finite set of states, summation is a finite set consisting of input alphabets, T is a finite set consisting of tape alphabets, del is a transition function, Q naught is an element of Q which is known as the start state. Q accept and Q reject are the accepting and rejecting states. Here we will see the Turing machine represented as language acceptor. A Turing machine halts when no longer moves are available. If it halts in a final state, we see that it accepts the input, otherwise, it will reject the input. Here we will see the different variations of Turing machine. The first variation of Turing machine is multi-tape Turing machine. Second is non-deterministic Turing machine. Third is multi-head Turing machine. Fourth is offline Turing machine. And the last one is multi-dimensional Turing machine. Now we will see the recursive and recursively enumerable languages. The Turing machine may perform the three operations. It may halt and accept the input, it may halt and reject the input, or it may never halt. First, we will see the recursively enumerable language. This is a TM. In TM, there exists a language which accepts every string, otherwise not. Recursive language. This is a TM language which halts on every string. Now, the properties of Turing machine. A Turing machine can recognize a language if and only if it can be generated by a phase structure grammar. Now we will see what is church hypothesis. A function can be computed by an algorithm if and only if it can be computed by a Turing machine. This is a statement given by Alonzo Church in 1936. Also in 1936, before learning of Church's work, Alan Turing created a theoretical model for machines, which is known as Turing models, which consist various symbols on tape. Turing machine is an abstract representation of a computing device. It is more like a computer hardware than a computer software. The Church Turing thesis basically concerns on effective or mechanical method in logic and mathematics. Here, M method is effective or mechanical just in case when M is out in terms of a finite number of exact instructions. M will be carried out without errors and will produce a result in finite number of steps. The assumption that the intuitive notion of computable function can be identified with different partial recursive function. This statement was first formulated in 1930s by Alonzo Church, therefore it is known as Church-Turing thesis by his name. This thesis cannot be proved. The computability of recursive function is based on the following assumptions. Each elementary function is computable. If f be a computable function and g be another function, then g can be obtained by applying elementary operations on the function f. Any functions become computable if it is obtained by the first and second rule repetitively. Here is a simple example of the Turing machine. Let us construct a Turing machine for the language which consists any number of zeros and only even number of ones. Here 0 and 1 are the input. First of all, we'll draw the finite state machine for the given language. Q0 is an initial state, Q1 is a next state, and Q0 is also the final state. On giving 0 input on the Q0, it remains on the same state. On giving 1 input, it reaches to Q1, and on giving input 0 on Q1, it remains on the same state, and on giving input as 1, we reach to the final state Q0. Now we'll see the same example. First we have seen from finite state automata, and for the same example now we will draw the TM model. Here this is the starting state, this is the next state which on performing right or left operations we reach. This is the halt state where when we get the blank as an input on the tape, or either we will move left or right, it will halt the function. This is on giving q1, on giving 0 input on the tape 0, and on moving right we reach to the same state q1. This is simple example of TM model for the given language. Thank you.